So example number 2 now, we've got a 0.5 kilo trolley that is pushed at a velocity of 1.2 meters per second into a stationary trolley of mass 1.5 kgs. Again, the two trolleys stick together to each other after the impact. Calculate the momentum of the 0.5 kilogram trolley before the collision and the velocity of the two trolleys straight after the impact. So make sure that you're highlighting the key information before. So we've got 0.5 kg trolley has got a velocity of 1.2 meters per second first. Then we've got, we know what the mass and the initial speed of the second trolley is, because we're told that it's stationary. Okay, so stationary is a key word. The two trolleys stick together, so just like the last example, just like example number 1, this is going to be a perfectly inelastic collision. First of all, they want us to calculate the momentum of the 0.5 kilogram trolley before the collision. So let me just do that separately. So to calculate the momentum of that first trolley, and I'm going to call it trolley A, all I do is, first of all, make sure you're drawing a picture. Okay, so the momentum of A is going to be the mass of A times the initial velocity of A. And again, this is all before the collision. We know the mass is 0.5 kilograms, and we know that the initial velocity is 1.2 meters per second. So that gives me 0.5 kilograms times 1.2 meters per second, and that gives me 0.6 kilogram meters seconds minus 1. So that is just the momentum of trolley number A. Okay, then we'll go ahead and we'll do the next part. Okay, so for part B, they want the velocity of the two trolleys, the two trolley system it might be called, or the two trolleys that are stuck together directly after the impact. So again, I will draw a before and after picture. This time I've put trolley A back into the picture because I know it's going to be part of the system. The initial velocity of A, the mass of A, and the initial velocity of B and the mass of B. And those are all known quantities. Then I've got the total mass, which is basically just going to be the sum of the other two masses. So A is 0.5, B is 1.5, so the total mass of A and B is just going to be 2 kilograms. And what we're looking for is that common velocity, or the velocity of the two-car system, whatever you want to call it. Okay. So now we apply conservation momentum. I'm going to do the long way. I know we've already calculated the momentum of A, but I'll just do it the normal way that we would, as if we hadn't. So I know that the mass of A is 0.5 kilograms times the initial speed of A, which is 1.2 meters per second. Mass of B is 1.5 kilograms, but the initial velocity of B is 0. So that means that B is going to have no momentum before the collision. The total mass after the collision is 2 kilograms, and we've got that common velocity. So all we do is just work our way through the numbers then. The momentum of B before the collision is going to be 0. The momentum of A before the collision is 0.6 kilogram meters per second, and we've already worked that bit out. And that's going to be equal to twice the final velocity, or that common velocity. So that means all I need to do to isolate V is to divide both sides by 2. So we do that. 0.6 divided by 2, well, the 2 on the right hand side will divide by the 2 that you're going to divide it with, and it will cancel out. And on the left hand side, you've got 0.6 divided by 2. Of course, that works out to be 0.3 meters per second. And of course, that's the common velocity. And again, just do a quick sanity check. Okay, check it as regards the momentum vectors. total momentum before the collision, we had already worked out to be 0.6. Okay, so if I draw the momentum vector, it might look something like this. So there's my momentum vector before the collision. This one has 0 momentum. After, have to have the same momentum. So there's the momentum after collision. It's got to be the same. And if you think about it, we've got a mass of 2 kilograms, and I've got a common speed or a common velocity of 0.3. So 2 times 0.3 is going to be 0.6, which is exactly what the momentum was before the collision. Okay.